Hello, third year. This video will introduce something called quartiles to you and interquartile range. So, quartiles and interquartile range are really a way for us to assess our data. So, we'll get to that in due course, but we're going to start with the mechanics of how do we calculate a quartile and an interquartile range. All right, and then we'll get into the whys and wherefores in a little bit of time. Now, hopefully, there's a bit of a clue here. If you look at the first part, or first half really, of the word quartile, it sounds a little bit like quarter, yeah? And we all know that quartering things is chopping them up into 4 bits, yeah? We're dividing it up into 4 bits. Well, that is exactly what you're going to do. You're going to take a data set and you're going to chop it up into 4 equal-sized pieces. Now, there are 3 possible scenarios for the way this could happen, because in the same way as when you calculate a median, remember when you calculate a median, sometimes it's an exact value and sometimes it's halfway between 2 numbers. Well, the same thing can happen when we do quartiles. So we're going to have a look at each of these scenarios in turn. The sample size, remember this value of n, increases by 1 in each case. So if we just have a quick look, let's just do a quick count to see how many bits of data we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now I need to take all those away. So 17 bits of data there. I know that the next one is 18 and the next one is 19 because I've set it up that way. Okay. So we need to split this first set of data in half. All right. So that's how we start when we're finding quartiles. Before we find the quarters, we find the half. That's the easiest way to do it. So to split 17 in half, that's an odd number. So I'm going to want 8 pieces of data on one side, 8 pieces of data on the other, which means that will give me 16, which means I've got to take out the 17th number if you like. So let's count in. Again, I'm just going to use the highlighter to count this in to show you what I'm doing. So 1, 2, 3, 4, 5, 6, 7, 8. I think that is my quartile 2. Okay, sometimes called a middle quartile. Let's check. So I've got 8 bits of data on the left-hand side of that 10. I should now have 8 bits of data on the right. 1, 2, 3, 4, 5, 6, 7, 8. So far, so good. So I've halved that data nice and neatly, haven't I? Let's just take these highlighters away. I'm really just using highlighters to show you what I'm doing. Okay, if I was in class in front of you, I would be counting them on the board. But this just shows you what I'm doing because I'm conscious that you don't see my pen working. You just see things appearing on the screen when you're watching. Right, now that I've got 8 bits of data on the left, 8 bits of data on the right, I need to split those sections of 8 into 2. Okay, so I've halved the data once, I'm going to half each section again. So half in 8, it's easy, isn't it? It's going to be 4, so it's going to be 1, 2, 3, 4. I'm going to have to put the quartile in between those 2 numbers. Can you see that? Because if I put it in between those 2 numbers, then I get 1, 2, 3, 4. So I've got an even split there. I've got 4 on the left, 4 on the right, because my quartile is right in the middle. Okay, so my quartile is right between those 2 numbers, yeah? It's not exactly on either one, it's between the 2. Just tidy that up without rubbing out what the work we've done. Okay, same on this side, 1, 2, 3, 4. The quartile is right between those 2 numbers. So that's quartile 3. Between 15 and 17, halfway between those 2, 16. And just to verify that, we have 4 bits of data on the left of quartile 3 and 1, 2, 3, 4 bits of data on the right of quartile 3. Okay. Look at your data now. You should see that that is quartered up nice and evenly, yeah? So 4 bits of data in the first quarter, 4 bits of data in the second quarter, 4 bits of data in the third quarter, and 4 bits of data in the fifth quarter. All right. Now I realise that we're quartering things, and you might think that quarter and 4, there's some sort of relationship there. Well, there is, we know there is, but in this case, I promise you it's coincidence that each quartile has 4 bits of data in it. All right, it's perfectly possible that each quartile might have 1 bit of data, 2 bits of data, 3 bits of data, 4 bits of data, 5, 6, any number of bits of data in each quartile. Okay, as long as it's evenly spread out, the number of bits within each quartile doesn't matter. So please don't get stuck on that. It's coincidence that there's 4 bits of data there. Okay, a quartile can contain any number of bits of data as long as it's evenly spread, and I hope you can see why that's the case. Let's just take that out. All right, next scenario. It might be wise, it's entirely up to you, but it might be wise to pause the video at this point and just go back and make sure you're familiar with that, make sure you can work out the steps. If not, send me a question, let me know when you stop understanding what's going on. Next scenario, scenario 2. N equals 18, so that means we're going to split our data in half. That's going to be 9 on each side. So let's just go for it. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. To make that work, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. That means that my quartile is going to be halfway between. It's got to be smack in the middle there. So that's quartile 2. Now, halfway between 10 and 10, just so happens to be 10. Okay, let's get rid of the yellow and the green. Now we need to split the halves in half. Okay, so we'll start with yellow. I've got 9 bits of data on each side, so that's going to be 1, 2, 3, 4 and a half. Yeah, and if I go from the other side, 1, 2, 3, 4, that's an even split. Now for that to work, I have to make 5 quartile 1. Okay, so by taking out that 5, I create the even split of 4 and 4 bits of data. Okay, let's have a look again here. 1, 2, 3, 4. We expect this to follow the same pattern, because if it doesn't, it's not even. For that to work, to have 4 and 4, we need to take the 15 as quartile 3. Okay, now you can see there, we have that nice, even, symmetrical spread of data. 4 bits of data to the left of the 5, 4 bits to the right, 4 bits to the right of quartile 2, and then finally 4 bits to the right of quartile 3. So we've got this even split of 4 bits of data again. Again, that's coincidence, okay? It's not, there can be any number of bits of data in each quartile as long as it's evenly spread out, all right? So that's scenario 2. So the first scenario, if you look at it, we've got 2 halfway and 1 exact value. For the second scenario, we've got 2 exact values and 1 in between. I wonder if you can take a guess what the third one's going to give us. So 19 bits of data in this last example here. 19 split in half, what's that going to be? 9.5. So how's that going to work then? Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now if I do the same on the other side, I'll miss that 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I now have even numbers on either side. For that to work, 10 has got to be quartile 2. All right, now we have to half the halves again. So we have how many bits of data to the left of 10 here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So to half that again is going to be 1, 2, 3, 4. Change of color. 1, 2, 3, 4. So for that to work, 5 has got to be quartile 1. Now, just looking for symmetry, 1, 2, 3, 4, the other quartile's got to be an exact value, 1, 2, 3, 4. Otherwise, we're not going to have symmetry. So that has to be quartile 3. All right, so that's us. That's how we calculate quartiles. Okay, you can see it there. We've got 4, 4, 4, and 4. 4 bits to the right and left of each of the quartiles, which is exactly what we want. So scenario 3, we've got 3 exact value quartiles. Okay, so that's the third possible scenario that might occur. Hopefully what you're noticing, well, I hope you notice, quartile 2 has a special name. It happens to be 10 in every case, but quartile 2 is known by something else. You already know what quartile 2 is. Quartile 2 is a middle number in every case. Well, what's the other name for the middle number? You know it. Median. All right, quartile 2 is the median. Okay, so it can be referred to as the median. It can also be referred to as quartile 2 or the middle quartile. All right, sometimes you'll find quartile 1 referred to as the lower quartile and quartile 3 referred to as the upper quartile. I prefer the numbers, but either way works. One other thing that we can be asked to do with quartiles is to find what's called the interquartile range. The interquartile range, which you'll be glad to know we can abbreviate to IQR. All right. What's the range? You know what the range is. With the range, you take the largest value, don't you? And you subtract the smallest value. We did that in the last exercise. Surprise, surprise, with the interquartile range, we take the largest quartile and take away the smallest one. So that's going to be 16, take away 4.5, which should give you 11.5. Okay, so that would be your interquartile range. For the next one, I'm going to do the interquartile range. The IQR, I'm going to abbreviate it, is going to be 15 take away 5, which we know is 10. And I'm going to introduce to you something called the semi-interquartile range. Okay, you'll be pleased to know that abbreviates to SIQR. All right, now this SIQR, semi meaning half, is half of the interquartile range. So in this example, that would just be 5. Okay, and last but not least, I'm just going to move this down a little bit if I can. Just a little bit close. Very, very quickly for scenario 3, the interquartile range, largest quartile, take away the smallest one, 15 minus 5, that's also 10, which means the SIQR, the semi-interquartile range, is the half of the IQR, so the IQR divided by 2 is going to be 10 divided by 2, which is of course 5. Okay, so there's quite a lot of new terms in there, quite a lot of possibly new information. The key things you need to take away, quartiles are about quartering the data set. Okay, so you need to split your data set into nice, even quarters. Sometimes that will involve an exact value, sometimes that will involve going halfway in between. If your data set is not quartered equally, if you don't have the same number of bits of data in each quarter, something's gone wrong. That's the most important thing. The interquartile range and the semi-interquartile range for people like yourselves is going to be pretty easy. Okay, it's a simple subtraction and a division, nothing difficult. The new thing is finding quartiles. Please take your time with that. If you get stuck, if you have any questions, you know where to get me for help. Teams chat or Glow email is absolutely fine. Okay, remember, stop the video, have a look at things. If there's something I'm doing in the video that you don't understand, tell me at what time you stop understanding, and I will come back and I will do what I can to help you with that. Okay, it's really no problem. Good luck with the questions. Please be in touch if you need help.